The learning topic for today is applications with lines, and we are going to discuss this topic using applications of linear models. So in many day-to-day applications, two variables are related linearly. By finding the equation of a line, we produce a model that relates the two variables. So there are three examples of linear models that are also applicable to daily life. So the first one is a linear cost function, and that models the cost, which is denoted by C of X, to produce X items. So I want us to take a few moments to look at all of the pieces of this. So C of X is composed of mx and then plus b. So mx represents the variable cost for producing X items. And then B is the fixed cost for producing X items. So we want to notice fixed means it does not change, which means if I produce one item, the fixed cost is going to be the same as if I produce 100 items. It doesn't change, it is fixed. And then the total cost is represented by C of X, which is the variable cost plus the fixed cost. So if we are producing items, we probably want to sell them, and if we sell them, we're going to sell them for a particular amount of money. So our revenue function, which is denoted by R of X for selling X items, can be found by determining P times X. And this represents the price, P, per item times the number of items sold. And the number of items sold is our X. So then we have our last function, which is a combination of the first two. And so if we think about profit, profit is what I actually end up with in terms of money after I sell my items and after I take into consideration that it actually cost me a certain amount of money to produce these items. So P of X, which is our profit, is our income minus our cost. And so that is why P of X is our revenue minus our cost. So for example, at a summer art show, a vendor sells lemonade for $2 per cup. The cost to rent the booth is $120. So that is a set amount. Notice it's $120 versus the $2 is what we're selling the lemonade for, and it's $2 per cup. Okay, so we're selling, so that is income. $120 is our fixed cost. It's not changing. So the vendor knows that the lemons, sugar, and cups cost a total of 50 cents or $0.50 for each cup of lemonade produced. So that is also a cost. Okay. But it is 50 cents for each cup or per cup. So that is a variable cost. It's going to cost this person more money if they make a lot of lemonade. It's not going to cost them much money if they make very little lemonade, but then they won't have enough to actually sell. Okay, so the fixed cost, remember fixed cost is our variable B, and our fixed cost is $120. Our variable cost is represented by M times X, and M is the amount that it cost per unit or per item, or in this case per cup. And so that would be 50 cents. Notice I say 50 cents, but I'm using a dollar symbol with our decimal 0.50. So 50 cents per cup, or for each cup, which would be X. So 50 cents per cup. And then we are asked to determine our cost function. So C of X is equal to MX plus B. Therefore, C of X is equal to 0.50 times X plus our fixed cost of 120. And then later on in this course, we're going to actually also determine what our revenue function would be and what our profit function will be. All right, so you have one question, and the question is, a parking garage charges a flat fee of $2 plus $1.50 per hour. And I want you to write a linear function to model the cost for parking T hours. So make sure that when you write your function, you use proper function notation. And I'm asking you to please use the variable T.